Good morning and a warm welcome to today's webinar, outlining the cost-saving parameters for hybrid and electric integration in the fleet. My name is Sita Kelsey and I will be your moderator today. In a moment, I'll be turning things over to our speaker, but first, let me explain how you can get the most out of this event. To improve your viewing and listening experience, you can move your webcast windows around by dragging on the title bar or resize them by clicking on their lower right corner. At the bottom of the screen, you'll find multiple application widgets. A copy of today's slide deck is available in the green resource list widget. We welcome questions about our topic and will answer as many as we can following the presentation, but feel free to submit yours to the queue at any time. Just type it into the Q&A window on the left-hand side of your screen and hit the submit button. Please also be aware that today's session is being recorded and will be available for on-demand viewing. You will be notified by email when the archive is available. Now, let me introduce today's presenter, Sondre Henningsgård, Managing Director at the Maritime Battery Forum. You can find more information about our speakers by clicking on the speaker bio widget at the bottom of the screen. With that, let's get started. Sondre, the floor is yours.
Thank you very much, Sita. Yeah, like Sita said, my name is Sondre Henningsgård. I am Managing Director in the Maritime Battery Forum. When not working in the Maritime Battery Forum, I'm also working as a discipline leader in DNV GL Maritime Advisory. And today I will talk a bit about batteries in maritime, a bit about the motivation, why batteries, and what does the uptake look like? What does the battery-powered fleet look like? Firstly, quick about Maritime Battery Forum. With any technology that is relatively new, it's great to get all the different players in the same group. Some knows a bit about batteries, some knows about maritime, some knows about regulations. Getting everyone together makes you see the whole picture, and that's the whole purpose of the Maritime Battery Forum. Anyway, without further ado, let's just kick off this presentation. Normally, when I start my presentations, I open with this slide, this dark black slide, and I ask the question to the audience, which is a bit difficult since this is a webinar. What do you see on the screen? What I see on the screen is my bedroom at age 5, when I was scared of the dark, because in the darkness there are monsters. Now, for a ship owner, this is no different. Ship owners are also scared of the dark because in the dark you have new technology, regulations, etc., that can alter the way you need to do your operations. And my task is a bit like what my father did when I was 5, and that's cast a bit of light on the situation and show you that the monsters in the dark are in fact not so scary, although we'll be talking about batteries today. So first, a little bit about motivation, why batteries. So this is the first motivation, of course. Engines make noise. Batteries do not. That's the first start, but that's not really why we are working on batteries. For a luxury yacht, for sure, the noise is important. For a harbor with people living in it, of course, the noise is important, but what we are talking about is more about energy savings. Now, of course, addressing one of the monsters, batteries are a revolutionary new technology that has just been invented. At least that's the feeling I get when I talk to a lot of ship owners, but in fact, looking at electric cars, people think that Nissan Leaf is a revolutionary car. In a sense it is, because it was one of the first modern electric cars. But looking back, the first cars were in fact electric and preferred to be electric. So the example on the picture here is the Detroit Electric, which was produced between 1911 and 1916 with a range of 130 kilometers with a nickel iron rechargeable battery. In fact, at the year 1900, about 30% of all cars in the US, imagine that, in the US were electric. And And the picture in the middle bottom there, that's a New York City charging station for taxis in 1909. So batteries are not new. What is new is the technology we're talking about now and the application in maritime. So lithium-ion batteries, that's what we're talking about in general when we say batteries in maritime. A couple more motivations. Of course, greenhouse gas is an issue. And comparing to heavy fuel oil, far left column, we compare a variety of fuels and energy sources. It's important to remember that a battery is not a fuel, it's an energy storage. But from the figure here, you can see that hydrogen and battery are the two only sources that can get close to zero emission. Although it depends heavily on how you produce and how you charge those, the battery and also hydrogen for that matter. If we look at other emissions like NOx, SOx particles, your more local pollutants, if you like, compared to HFO, again, hydrogen and battery are the only ones that can go to absolute zero, again, depending on the energy mix used to produce it. Of course, another motivating factor is cost. This is a graph put together based on some historic reports and some wide predictions. What's important to notice here is that the light blue long graph that goes down from 1600 and ends at 2025, that was the old market prediction for battery cell costs. And then a few years after that report was released, the dark blue line was the result. So they shifted the whole report a little. And the green cross at the bottom at the year 2016, that was the market leading price for this particular chemistry. This is not a general battery cost, this is for a particular chemistry. What is important to notice is whenever you read in the news that, for example, Tesla has as a target to sell batteries for $100 per kilowatt hour, and then you think, oh wow, that sounds good, I want to use that on my ship. Please remember that that is for the battery cell, not for the battery system. So if we look at the battery system cost, which is represented by the black crosses and the black stapled lines, there's a wide range in the cost, although this is also continuously being pushed down. So it's a bit difficult to stay on top of the prices because the market is developing so fast. So this is a bit of the more, let's say, high-level motivations: cost, emissions, comfort, these type of things. But why do we talk about batteries and energy saving and using energy in a smarter way? The next slide is, in a way, my favorite for showing why batteries can be used basically to enhance and improve the way we use energy. In most presentations that I give, I also ask after this video, what did you just see? And what did you see? Well, you saw a 2-ton family car destroy a Lamborghini in a drag race, but that's not the point of the video. The point of the video is, of course, acceleration. And this curve is meant to illustrate that. This is a measurement from a Tesla and a Dodge Hellcat. And the whole point with this figure is showing the purple curve for the Tesla, that once you flick the switch with a battery and an electric motor, you have instant maximum torque, more or less. And the mechanical system in the Hellcat takes some time to ramp up. And this whole area here between those graphs, this represents improved responsiveness, safety, the potential to moderate the system. And this is to a large extent why we are talking about batteries. On one hand, batteries, there is nothing that beats batteries for efficiency. So if you can go all electric, like for example ferries, there is nothing currently that can beat batteries on efficiency. However, when it comes to energy and range, Currently, there is nothing that can beat diesel, which is, of course, not good. So this ability to moderate the system represented here by Tesla and Dodge Hellcat is really what we will see the most of in the near future. And this fast response in the battery enables a bunch of benefits and possibilities, some of them summarized here. For example, spinning reserve being a very interesting one. Typically in offshore vessels, you have additional generators running just in case you need the extra energy. With the battery, we could rename spinning reserve. We could just call it static reserve or something like that, because the battery isn't really running, it's just there. Same with optimizing load. Having a battery that responds faster than the mechanical system means that you can let the mechanical system do what it's good at and let the battery handle everything else. Harvesting energy, a very interesting one for batteries. In electric cars, it's really easy, since whenever you're braking or going downhill, you can regenerate power and recharge your battery. When you talk about vessels, it's a bit more tricky, since a vessel is in a way always running uphill, always braking in water. But if you have cranes or cargo handling equipment or whatever where you can regenerate, today we are wasting that energy. Tomorrow we will be making good use of that energy. So I will just go quickly through a simple example. This figure here is a power over time curve. It could be a load curve from a vessel maneuvering in port. It could be an offshore vessel on dynamic positioning. It could be cargo handling with cranes. The whole point is that it's a very varying load. And if we bring up a typical fuel consumption curve for a diesel engine, you will notice that at around 80%, which is a very typical optimal load point for a diesel engine, you're using as little fuel as possible to produce energy. And if we go back to our example with the curve and add a couple of lines, the green line represents the optimal running point for a fixture's diesel generator in this case. And the red line represents the maximum output from that engine. And first of all, you'll notice that the system is never running at the optimal point of the engine, or at least close to almost never. And there are a couple of peaks that go above red. So consequence is, of course, that we have to turn on another engine. So this means that in the fuel curve, we are now moving from, say, for example, 80% to 40%. So significantly increasing our fuel consumption. However, if we have a battery that can respond faster than the system, we can allow the engine to run at the optimal load, the green line here. And anything above that, the battery will discharge, and anything below, the battery will charge up. So a couple of examples of what this could look like in more real life. The left-hand figure is from a PSV, where back in the good old days of conventional running many generators, the red and blue lines in the middle moved into the bluish battery line at the bottom and the purple one generator at the top, which resulted in engine also means that you don't do any maintenance on that engine. So I'm not going to spend too much time on this calculation example, but let's just say that you have an offshore supply vessel. This is a very oversimplified calculation, but anyway, let's say you have 4 engines, because that's the requirement. You need to have that power available. Relatively high fuel consumption, and you have 4 engines running. The result is 9 tons of fuel per hour per day, and 96 hours of operation, which goes on the maintenance cost. Now, let's say we have a battery instead, so we can run 1 engine at 80% load, significantly lower specific fuel oil consumption. Result is we save about 18% fuel, Like I said, this is a very oversimplified calculation. In real life, actually PSVs are showing savings of 20 to 30% in dynamic positioning. And of course, we are in this fictitious example again reducing to 25% of the previous maintenance. My next slide moves a bit into one of the most important aspects when talking about hybrids and batteries. Please remember to consider the whole system. Typically, when I work with companies that are interested in developing vessels, hybrid vessels with batteries, a lot of the times they end up taking a conventional vessel and adding a battery. Sure, you can do that, but then you miss out on most of the benefits. You're not able to optimize in the best way. You're just adding a patch to a system that's not optimized in the first place. So make sure that you start out with a full perspective. Consider designing around the battery, perhaps. Just make sure that you don't do as you always have done, because then you will end up with what you always had and an extra battery. So let's move on to the fleet, since that's probably interesting for most of you. Okay, so first I thought I would just show approximately what the fleet looks like. As you can see from the pictures that just popped up, there are quite a few different vessels, which we will get back to in a little bit. So basically, this is what the fleet looks like. There are quite a few car ferries. There are quite a few offshore vessels, a lot of passenger vessels, some yachts, some tugboats, and then there's a lot of different stuff popping up. And I made this figure not too long ago, and I realized that I should add a couple more lines. There is so much going on in the world of maritime batteries, and the uptake is going so fast, it's a bit difficult to keep track of everything. Now, of course, in the Maritime Battery Forum, we have a ship register for battery-powered ships, hybrids and all-electric. So I thought I would show some numbers from there. So first of all, this is development in ships based on the year that the battery is installed. So some of these are retrofits. So let's say a vessel in 2015 can potentially have been built in the 90s or whatever and have a battery retrofitted later on. More will be delivered in 2018. I will get back to the details, but we have just moved the register from our old platform onto a new one, so we are working on updating the numbers there. The total number of vessels, if we include the order book, are currently around 300 vessels. So it's been going up quite fast. If you do the math on this figure, you will see that the growth rate is at around 30% per year in number of ships. And in battery size, it's slightly larger than 30%, but that's mainly due to a lot of ferry projects being realized in the past couple of years, which have larger batteries than what was the case earlier. That being said, though, there are larger vessels now looking into double-digit megawatt-hour battery packs. So the rate might actually increase even faster for the battery capacity. If we look at where they are, Norway is, to a certain extent, of course, on top. Norway is being brought up quite often when it comes to battery-powered ships due to a lot of incentives towards zero emission, particularly for ferries operating in Norway. France has a lot of canal boats and also some other segments represented. Most of these are older vessels using lead-acid battery technology, but there are quite a few new developments also. Quite interesting, USA, also in the top 5. One might not think that they would be high up on the battery-powered vessels, but they're actually growing quite fast, and there's a lot of interest in California and Washington. And it might surprise some of you to learn that the first all-electric ferry in the US just started operation in Louisiana. So are the vessels new builds or retrofit? From a technology perspective, this can be a bit interesting. About 1/3 are retrofits and the rest are new builds. In general, it's easier to get a good integration if you do it as a new build, but there are also quite a few opportunities to improve so much that you would actually go for a retrofit of batteries. And the next slide gives a bit of an impression of segments and who are actually doing retrofits. So just to guide you through this figure a little bit, first of all, on the x-axis, you'll notice that there are quite a few different segments that are now working on batteries for their vessels. It's not just ferries and passenger vessels, which is what I hear most frequently. Lots of offshore shuttle tankers with batteries, regular tankers, product tankers, quite a few tugs. Currently, there is a series of 4 tugs, all electric, being built in Turkey. Yachts, naturally interesting to have batteries on yachts. Aquaculture, cargo ships with cranes and so on, cruise vessels, lots of different segments. What you will notice is that for ferries, some are retrofitting. They actually fit the previous figure quite nice, with about 1/3 being retrofitted and the rest as new builds. Offshore vessels, on the other hand, is perhaps the most interesting segment for retrofit, since offshore vessels traditionally have so strict redundancy requirements that they, from an energy production perspective, are quite, well, in lack of a better word, hopeless designs. Lots of engines, always running at low loads, unnecessary use, unnecessary number of engines if you have a battery. So only recently was the first retrofit done where they actually removed one generator and replaced with a battery. For most of these retrofits, they have added a battery, and still it pays off. This slide shows a bit on technology and how it's being used. Most vessels will be hybrid if we start with the figure on the right. Hybrid or plug-in hybrid. Pure electric vessels, for sure, there will be quite a few pure electric, or pure electric is perhaps a bad choice of words. All battery powered is more correct. But for now, they seem to be more the exception. So ferries, passenger vessels, vessels that have really predictive operational profiles, they go all battery. Most others, they will be hybrid, where we combine battery and some form of fuel. Perhaps more interesting than will the future vessels have batteries is which fuel will be supporting the batteries. The reason why we split between plug-in and hybrid is simply that some vessels are meant for charging at shore and some are not. At the same time, I would advise not to use the figure too absolutely, because quite a few projects don't state if they are plug-in or not. So it's just to show that there are both. And the propulsion and other, the figure on the left, the whole point of this figure is basically to remind people that you don't necessarily have to use the battery for propulsion. In the MBF ship register, if projects are ticked off if they are meant to be used for propulsion or other. So if it's meant for propulsion, it could also be used for other purposes on the vessel. In this figure, the ones that are other are geared bulk vessels, so vessels with cranes. And just to show you, there are quite a few different chemistries that we are talking about, and this is just a highlight of some of them. For example, NMC chemistry. This is the one that is being used the most in maritime at the moment. There are a ton of different versions of NMC or NCM chemistries, but the ones that are doing most progress in maritime currently are NMC, which probably have about 75 to 80% of the market. LFP, which is iron phosphate, which more or less covers the rest. And then there is one technology that not many are using at the moment, but that will probably become a very interesting technology going forward, and that's LTO, where you use titanate. And this gives you some higher power and lifetime capabilities. But also which leads to increased weight and cost. Then just to show a little bit more on segments, of course, ferries, offshore vessels, passenger vessels, and so on. There are quite a few. And then when I go around the world giving presentations, there seems to be this perception that everything is happening in Norway and Scandinavia. So I thought I would just show briefly what is actually the Norwegian share of these top 10 segments. And it looks about like this. Norway currently, with the sailing fleet and the order book, has somewhere in between 35 and 40-ish% of the fleet. But there is so much development now happening in the rest of the world that this share of the market will probably shrink quite soon. Still interesting to observe. So we are approaching the end of my slides. What will actually come? To me and people I talk to in general, batteries will be a standard component in all ships. The question is more who will be all electric, and for the ones that don't go all electric, what fuel will be the support? What will be the hybrid configuration? Will we continue with diesel? Will we switch to LNG? Will we go all the way to zero, at least in operation, and use fuel cells and hydrogen? What will be that added fuel? There are various requirements coming in, ECA zones, clean cities, sulfur caps, lots of governments focusing on emissions, United Nations, and so on. The cost focus will naturally not stop, and this is probably a key thing when we talk about batteries. Not always, but most of the time, batteries on new concepts lead to a higher investment cost. Not all of the time, but sometimes. If you can remove engines and rearrange how you use your machinery, you might actually end up with a cheaper vessel than if you had gone for a conventional setup. Customer requirements are also something that will be very important and drive the change. Looking at the cruise, local pollution, and so on, and which segments will thrive. Basically, all segments will be developed quite fast, but for obvious reasons, short sea shipping, coastal fleets, and so on will be the first ones to adopt new technology. This is simply because it's easier to set requirements for local authorities. Typical segments that will adopt batteries quite fast now: fishing and aquaculture, workboats and patrol boats working in harbors. Most passenger vessels and ferries will be all electric or hybrid. A lot more offshore coming on. What I didn't show, since I showed the merchant fleet, now is that there are several offshore rigs that are now considering and installing batteries. Short sea shipping in general, it's easier to adapt technology when you have shorter routes and local requirements. And basically any ship type that has redundancy requirements, for example, a product tanker. When maneuvering, can you switch off an engine in the design? Can you remove one? And so on. Bulk vessels with cranes, this will be a standard component. The business case is quite outstanding for bulk vessels. And just to show the number of segments we currently have, I took an extract from our ship register, excuse me, which looks a bit like this. So quite a few different vessels. It's not only ferries, it's not only passengers. Batteries are popping up a lot of places. And this information is, of course, available if you would like to see it on a more regular basis. We have the ship register. It has now been moved from our current platform, so you can send me an email if you have any queries about that. In this register, we include a lot of information like market size by number of ships, megawatt hours of battery suppliers, system integrators, location, chemistries, technology, yards, and so on. And this is, of course, included in Maritime Battery Forum membership. So that's all I actually wanted to go through right now in this presentation. So I hope it gave you some insight into what the market looks like. I hope it gave you some insight into the motivation of using batteries. Of course, batteries don't grow on trees, but they present a green and improved business case for the future going forward. So with that, I'm ready for your questions. Thank you.
Well, thank you, Sondre, for that outstanding presentation. Really good overview of the topic in hand. As we stated at the beginning, any questions that come in, we'll try and ask now. But if not, we'll be following up following the broadcast with any other questions that we don't have a chance to answer today. So, Sondre, one of the first ones we've had in, you mentioned earlier on in the presentation about lithium-ion battery price trends. But in general, what are the costs associated with the integration of this technology?
That's a good question and a tricky question. It depends, which is sort of my favorite engineering answer. It depends. The different chemistries have different costs, and it also depends on how you want to use the battery, which is why I, again, repeat, look at the system as a whole. A lot of the time when I talk to people wanting to do concept developments, they have an idea that you either run on batteries or you run on diesel or LNG. It's important to understand that in a lot of cases, it's not either or, it's a combination. And understanding that can reduce the battery size or increase it depending on what it is that you want to achieve. So typically what we see for the cost is that you end up with a slightly more expensive vessel, not by much. Or in some cases, you end up with lower capex. But then calculating the return on the investment and looking at the total life cycle cost is quite important. Okay. I'm not able to present more detailed numbers than what I showed in the figure right here, but I'm sure there are quite a few suppliers out there who will be happy to provide quotes for your vessels.
Okay. A question about recycling here in regards to this technology. What would be the issues that we need to consider around recycling when it comes to the technology integration?
Yeah, another excellent question. I didn't cover that aspect here. It's actually one I get quite often about recycling, how environmentally friendly are actually the batteries. On maritimebatteryforum.com, at least it should be there, we have a life cycle assessment of batteries in maritime, which shows that for ferries and PSVs, it takes, well, for the ferry, it takes in between 1.5 months and 11 months, depending on the energy mix, to pay back the emissions from producing the battery relative to building a conventional ferry. That being said, though, what happened, and for the PSV, it was 1.5 months. So that was quite impressive. And then we go to the recycling question. So there we have a twofold issue. One, can we recycle the battery? The answer, yes, we can. Some of the battery suppliers have shown me their certificates for recycling, and they show a 97% or weight percentage of the battery system can be recycled. So that's quite good. Now, the second thing is that when you take a battery off the ship, like we are discussing with car batteries also, the battery isn't necessarily spent. The battery can be used, it just doesn't fit the ship operating profile anymore. So we're also having second life discussions. What can you use the battery for? And then we have all sorts of issues like how do you make sure that the battery is safe? How do we balance it? Where should we use it? Who should handle it? Lots of these questions, but the business case for that should be so good that this will actually work itself out quite nicely.
Mm-hmm. Okay. And I think with time constraints, final question I've got for you today. What's a good balance between installing batteries versus capacity on vessels?
I'm sorry, could you repeat the question?
Sure. The question here is, what is a good balance between installing batteries versus the capacity of a ship?
I'm sorry, I'm having trouble hearing the full question. You're breaking up a little bit.
Okay. What is a good balance between installing batteries versus capacity?
I'm not fully sure I understood the question.
Okay. All right, that was just relating to one of the questions that's come in during the broadcast. I've got another question here. Finally, most technologies indicate hybrids, but what about the fuel that's going to be used in conjunction with this?
Yeah, that's another question. I might not be the best person to answer, but of course, seeing what is happening now with IMO 2050 and ECA zones popping up, sulfur caps, and so on, what will be the fuel to go along with batteries? Probably LNG will have a big role in this. We've been saying for quite a few years that LNG will soon take off. Now it seems like we are actually at the point. Again, we've been saying that for a few years also, but now seems to be a good time, simply because diesel seemed to be a dated fuel. One of the ferry operators in Norway, they did a risk assessment on their fleet, and they concluded that 80% of their fleet was running on the wrong fuel, and that was diesel. So we'll see. It's interesting also to consider fuel cells and hydrogen, but there we are still a bit in the early days, in the start for maritime. There are a few projects going on, so I suppose we will see in let's say five years time, we'll see how the market adopts to that technology also.
Okay. All right, well, I think we've run out of time. Sondre, thanks once again for wonderful presentation and for answering those questions that come in. Just a reminder that any questions that have come in during our broadcast, we will be following up afterwards. As a reminder, you will receive a follow-up email that will include a link to view a recording of today's presentation. So if you found this event useful, please share it with your colleagues. We've also included the link to the Digital Week webinar series in the resource list widget. Please be sure to click on the link to register for other events in this series. Once you leave the event, a short survey will pop up in your browser window. We'd appreciate it if you would share your feedback on this event, as it helps us to provide you with content more interesting for you. So with that, on behalf of Connect 365 Maritime, we wish you a pleasant remainder of the day. Thank you very much.